this. This is, if anything, when you go home, you can try this out. Just call up a patch and just start changing the tables, the grain tables. And all of a sudden you went from strings to something like a little vocal pad, and it's pretty easy. Everyone follow that one? Okay, then that my time here wasn't wasted. Yeah, let's. What makes it unique is that, you know, for someone who's going into this from a sound design perspective, you can actually, well, say if you took a subtractor is a wavetable-based synthesizer, meaning each one of the little waveforms is stored in memory and it cycles through that little table. The same thing applies to the Malstrom, except you have the option of having thousands of little wavetables sitting next to each other and having the ability to access each one. So I'm going to set the motion, we can listen to this Foreman's saw, I'm going to set the motion to 0. And there's my oscillator, right? And I'm going to route that into a filter, and then I have this kind of a talking sound. But then at the same time, I can just easily, quickly scan through a different position on the oscillator index. And then you know, it seems simple, but in theory, what you have there is about 127 different synthesizer wavetables, just in what you have right there. Now you multiply that times each one of these grain tables. You have I don't know, I did the math once, it was like 43,000 or something like that. Different possibilities of using just one single index as your oscillator table. But that's boring. I mean, there's no point in doing that when you have the ability to do things like these evolving sounds. So everyone understand that? Everyone kind of got it, you don't have to fully understand, but if you got a grasp on motion and index and shift. Okay. So with synthesizers, and I know I've given this presentation before at the producers conference in New York, but synthesizers always typically have the same architecture. It's pretty easy. If you understand how to use one synth, like Mr. Voyager over here, you can pretty much learn to program any synthesizer. There's usually 3 typical sections. You have an oscillator, just like here we have oscillator A, which usually routes into a filter, and then it goes into an output amplifier envelope section. So those 3 sections are the components that actually structure the tone of whatever sound you're playing. Malstrom is structured a little bit different. It's kind of backwards because it goes from oscillator into the envelope, and then gives you the option of going into the filter. And if you follow these little arrows here, you can see where it gives you the switches to direct the signal from the oscillator. So let me take this. I'm going to enable. You can actually run the single oscillator through both filters simultaneously. So you can see the arrow going through A, through the shaper. I don't have the shaper enabled, so you're not going to hear that process in the signal. But then it's going to each of the filters. So now we can hear it. I don't really hear too much going on. But you have the option of mixing different filter types. So with the Malstrom, you also have this option of taking the outputs from the filters. If the spread is set to 0, both the outputs of filter A and filter B are going to be mono. They're going to be equal on both the left and right channels. When you set the spread controller, it starts separating the two. So filter A is going to go to the left channel, filter B is going to go to the right channel, and you can start building stereo patches. Is the imaging? Can you hear the imaging back there? It's hard to discern in this room here, but take my word for it. Once you go home, you can play with that. Take your oscillator, route it to both filters, and then start playing with different filter settings, and you can see how to instantly create like this cool stereo patch by having both filters. You can set them both at low pass, but set different filter frequency, cutoff frequency settings, and then set the spread control to maximum, and then if you want to use two oscillators, what I demonstrated here, we're taking one oscillator routing it to two filters. Alternatively, you can take two oscillators and route them to separate filters with the spread control. Mimic the filter or the oscillator settings. It's a random filter. So I've got, if you understand, I've got two oscillators pretty much doing the same thing. I've kind of changed the parameters just slightly on each one, so what it does, you have similar sounds coming from both channels, but the difference is you create this stereo image.